Mixed kinematics problems. With any two of these equations, any kinematics problem with constant acceleration can be solved. Once again, these equations only work in situations with constant acceleration. And remember, zero acceleration counts as constant acceleration. It just has a value of 0. They also will only work in one dimension at a time. More on this when we get to two-dimensional kinematics. As a guide, here is when to use each of these equations. This equation gives you instantaneous velocity at time t. This equation gives you instantaneous position at time t. This equation gives you instantaneous velocity at position x. A car which is traveling at a velocity of 1.6 meters per second undergoes an acceleration of 1.2 meters per second squared over a distance of 40 meters. How fast is it going after that acceleration? Which would be the best equation to find the velocity of the car? Kinematics equation 3 is the best match to the given variables, since time is not even mentioned. First, simplify this equation. Right? Our initial position is 0, so we can get rid of that term. But we do have an initial velocity here. So we're going to solve this equation for v, which means just taking the square root of both sides. Make sure you do not separate these terms. They are connected underneath the radical. Then we plug in our givens, take the square root of this, and we get 9.9 meters per second. An object is traveling at a constant velocity of 2.5 meters per second when it experiences a constant acceleration of 0.5 meters per second squared for a time of 30 seconds. What will its velocity be after that acceleration? What would be the best equation to find the velocity of the object? Here are our givens. We have initial velocity, acceleration, and time, and we're asked about velocity. Nowhere in here is position mentioned, so we're going with kinematics equation 1. Just substitute in the givens and we get 17.5 meters per second. An object is moving with an initial velocity of 4.5 meters per second. It is then subject to a constant acceleration of 0.6 meters per second squared for 10 seconds. How far will it have traveled during the time of its acceleration? What would be the best equation to find the displacement of the object? In this problem, we are given information about time and we are asked about position. When you have time and position, that is kinematics equation 2. First, we're going to simplify the equation. We're going to assume we start at the origin, and then we're just going to substitute in all the givens and get 75 meters.